Hello students, now in this video let's see the types of graph. Now first of all let's see the types of an ordinary graph, means undirected graph. Let me say for undirected graph. Now first type is simple graph. What is simple graph? A graph with no self loops and multiple edges. Graph with no self loop and multiple edges is called a simple graph. For example, vertices are denoted by points also. I can take this one as such: V1, V2, V3, V4. This is suppose E1, E2, E3, E4 and E5. Here no parallel edge, no self loop is there. Fine. Then another type is null graph. A graph G with vertex set V, edge set E, in which the set of edges E is empty set is called a null graph. Means simply vertices are there: V1, V2, V3. There is no edge in between them. That is what? Null graph. Third type, weighted graph. Weighted graph. A graph G is in which weight is assigned to every edge is called a weighted graph. For example, suppose V1, V2, V3, V4, V5. Suppose here the weight 2, 3, 5, some weights are assigned 6, 4, 1. Some values are assigned, that is known as a weight, and if such a thing will be there, then it is known as a weighted graph. Then next type is a complete graph. Fourth, complete graph. A complete graph on n vertices is denoted by kn. K suffix n is a simple graph. Simple means it doesn't have loop, self loop or multiple edges. Simple graph that contains exactly one edge between each pair, of distinct vertices. Now suppose, let me give few graphs of this kind. The graphs Kn for n equal to 1, 2, 3, 4, 5. Let us exactly one edge between each pair of distinct vertices. So if K1 is there, then simply a vertex. This is K1. If K2 is there, then there is an edge between them. This is K2. If K3 is there, n is equal to number of vertices. N vertices are there. So if this is distinct vertices. So this is what? K3. If K4, 4 vertices are there, then there is an edge between each and every pair of vertices, but distinct. This is K4. Now K5. This is K5. Now here few notes. First, in a complete graph, there is an edge between every pair of vertices. Every pair of vertices. Another one, a complete graph Kn has exactly n into n minus 1 by 2 edges. Look at here. If 1, then it has 0 edges. If 2, then it has only one edge. If 3, then 3 into 2 means it has 3 edges exactly as such. You can check that part. Okay. Next type, fifth one, cycles. What are cycles? A cycle, it is denoted by Cn. For n greater equal 3, consists of n vertices v1, v2 and so on up to vn, and edges v1, v2, v2, v3 and so on up to vn minus 1, vn and vn, v1. This is what? A cycle. Example, the cycles, suppose C1 is not possible, C3, C4, C5 and C6. Let me give C3. It has 3 vertices and there is, and it will be closed. Then it is a cycle. Only one edge between each and every vertex, but it will become a closed figure. V1 to V2, V2 to V3, V3 to V4 and V4 to V1 as such, C4. Then one, 2, 3, 4 and 5. It is C5. Similarly, we can find C6. Exactly one edge and it will become a closed figure. Fine. This is cycle. Now next one, wheels. We obtain a wheel Wn. It is denoted by Wn. When we add an additional vertex to a cycle Cn for n equal to n greater equal 3 and connect this new vertex to each of the n vertices. In Cn by new edges. Means what? Suppose we have this cycle C3, then here let me take one vertex and I will add a new edge from that vertex to every vertex. This is W3. Again, if this is C4, then I will take a vertex here and this is W4. This is C4, C5, but I will take a vertex here. This will become W5. As such we can do it. Now next type, n cubes. N cubes. The n cube is denoted by Qn. Is the graph that has vertices representing the 2n bit strips or strings of length n. Two vertices are adjacent if and only if the bit strings that they represent differ in exactly 1 bit position. Let me give example. 0 and 1 is here. This is Q1. Then this 0 0 0 1. This is 1 1 and here 1 0. Then this is Q2. Exactly, difference is exactly 1 bit string. Similarly, you can obtain other also. Now, the next type is K-regular graph. K-regular graph. A graph G. A graph G is K-regular if every vertex of G has degree K. Has degree K. For example, a graph G, suppose this is given. This one also you can check. Here degree is 2, here 2, 2, 2. Every vertex have same degree, then that is a K-regular graph. So this is, I can say this is 2 regular graph. Now let me give few remarks here. For this Qn cubes, we can say this Qn has 2n vertices and n into 2 raised to n minus 1 edges. Also it is regular of degree n. It is regular of degree n. These are the remarks. I will give them to you so that it is helpful to you, or you can verify them using example. Remarks about the regular graph also. If G is a regular graph of degree 3, it is called a cubic graph. It is called a cubic graph. How does it? It will be as such. This is a cubic graph. Then a complete graph Kn is n minus 1 regular. Also, a complete graph is regular, but regular graph need not be complete. Regular graph need not be complete. Look at this is an example. This is two regular graph, but there is no edge in between these. So it is not a complete graph. Fine. Also about n cube, that result I have to give. Q1 has 2 raised to n vertices and n into 2 raised to n minus 1 edges. Also, it is regular of degree n, means it is n regular of degree n. Okay. Then next type is bipartite graph. Bipartite graph, a simple graph G is called bipartite. If its vertex set V can be partitioned into two non-empty disjoint sets V1 and V2. V is union of V1 and V2, and V1 intersection V2 must be an empty set. As such, if we can partition and such that every edge in graph in the graph connects a vertex in V1 and a vertex in V2. For example, suppose I have these 4 vertices here, these 3 vertices here. Let me draw the edges. Suppose this one, then this will be a bipartite graph. Here this one we can take in V1 and this one we can take in V2. Now last type of undirected graph is that complete bipartite graph. Let's see that one. Complete bipartite graph. A bipartite graph in which there exists an edge between every vertex in V1 and every vertex in V2 is called a complete bipartite graph. Complete bipartite graph. Okay, a complete bipartite graph with partitions V1 and V2 having m vertices in V1 and n vertices in V2 is denoted by Kmn. The graph K1n is called a star. Now let me give that some example. we do this is nothing but K18. Then suppose I have this, then here this is K33. As such, the various examples we can give. So this is about the types of undirected graph. Now in next video we will see the types of directed graphs. Thank you.